Hey everyone, welcome to our exploration of system design methodologies. When we look up at the night sky, we're not just seeing a random scattering of stars. There's an underlying order, a structure, a system to it all. The same goes for the technology that powers our world, even the apps on your phone. Just like understanding the life cycle of a star can unlock cosmic secrets, getting a grip on system design principles can help you understand how complex software and applications are built. Over the next hour, we're going to dive deep into this often overlooked but incredibly important field. By the end of this session, you'll have a solid understanding of the key concepts, processes, and even some of the pitfalls involved in designing and developing robust, efficient, and user-friendly systems. So buckle up, get ready to expand your digital horizons, and who knows, you might just start seeing the world of technology in a whole new light. So what exactly is system design? Imagine you're building a skyscraper. You wouldn't just start piling up bricks, right? You need a blueprint, a plan, a deep understanding of the structure and how all the parts will work together. That's essentially what system design is for software and applications. It's about defining the architecture, modules, components, and their interactions to create a system that meets specific needs. We're talking about efficiency, scalability, security, and of course, user experience. A well-designed system is like a well-oiled machine, everything working together seamlessly. Now, even with the best blueprints, things can get messy in the world of system development. Ever had an app crash on you at the worst possible moment? That, my friends, is a symptom of a system design flaw. We're talking about things like inadequate planning, poor communication, scope creep, and the dreaded integration issues. These challenges can lead to project delays, cost overruns, and even complete project failures. It's like launching a rocket into space. Even a tiny miscalculation can send you wildly off course. Just as stars are born, live, and eventually die, software and systems go through a life cycle of their own. We call this the SDLC, the Software System Development Life Cycle. Think of it as a roadmap, guiding us through the stages of a system's existence, from its initial conception to its eventual retirement. Understanding the SDLC is crucial because it provides a framework for managing complexity, ensuring quality, and delivering systems that meet user needs. It helps us break down the development process into manageable phases, making it easier to plan, execute, and control. So, what actually happens during software development? Well, it's a hive of activity with different teams and individuals working together towards a common goal. We're talking about activities like requirement gathering, where we figure out exactly what the system needs to do. Then there's design, coding, testing, making sure everything works as it should. And of course, we can't forget deployment, where we unleash the system into the wild. Each activity is crucial, like instruments in an orchestra, all playing in harmony to create a beautiful symphony of software. Let's make this a bit more concrete. Imagine we're building a ride-sharing app. First, we need to gather requirements, how many users, what features, payment integration, location tracking, the works. Then comes the design phase, user interface, database structure, system architecture, like designing the layout and traffic flow of a bustling city. Next, our talented coders get to work, writing the code that brings our app to life. We test rigorously, squash those pesky bugs, and finally we deploy, making our app available to eager riders and drivers everywhere. Now, let's zoom back out and talk about the SDLC in more detail. This is where things get really interesting. The SDLC provides a structured approach to system development, guiding us through the entire process from beginning to end. It's like having a detailed map when you're exploring uncharted territory. Without it, you're likely to get lost, waste time and resources. The SDLC helps us minimize risks, ensure quality, and deliver systems on time and within budget. The SDLC is typically broken down into several distinct phases, each with its own set of activities and deliverables. We start with planning, where we define the project scope, objectives, and resources. Then comes analysis, where we really dig deep into understanding the user needs and requirements. Design follows, where we create the system's blueprint. Next up, we have implementation, where the actual coding magic happens. Testing is crucial to ensure everything works as it should. Finally, we have deployment, where the system goes live. And of course, maintenance is an ongoing process, ensuring the system stays healthy and relevant. Now, throughout this entire process, there's one key player I want to highlight: the system analyst. These are the unsung heroes of system development, the ones who bridge the gap between business needs and technical solutions. They're like the architects who design those intricate skyscrapers, working closely with clients to understand their vision and translate that into detailed technical specifications. System analysts are problem solvers, communicators, and big-picture thinkers. They analyze business processes, gather requirements, design solutions, and ensure the final system meets everyone's needs. So there you have it, a whirlwind tour of system design methodologies. We've covered a lot of ground today, from the basic concepts to the intricacies of the SDLC and the crucial role of the system analyst. Just like exploring the vastness of space, understanding system design opens up a whole new world of possibilities. Hopefully, you now have a clearer understanding of the fundamental principles and processes involved in crafting the software and applications that power our digital lives. But this is just the beginning, my friends. There's so much more to discover, from specific design patterns to emerging technologies that are shaping the future of system development. So stay curious, keep exploring, and who knows, maybe you'll be the one designing the next groundbreaking app or system. And remember, the universe of knowledge is constantly expanding, so keep looking up.